Problem 5. Problem 5. Problem 6. Draw an orthorhombic unit cell and within that cell a 1, 2, -1 direction. Okay, so this orthorhombic unit cell is a unit cell in which the three dimensions are not equal to each other. Okay, whereas the angles are all equal to 90 degree. So if I draw this cell over here, so it will be like this. Well, it will just look like similar to the cubic structure, but the main thing to know is that all the three dimensions are different. So if it is A, then B, and then C, they are different. So axes are here. So now we have to show this direction 1, 2, -1. This direction can be shown in more than one way. Okay, so if you just simply take these numbers, so we can start from the origin and take a distance of 1, which is equal to A on the x-axis, and then 2, which is equal to 2B on the y-axis. So we can extend it like here, and then a distance of -1, which is equal to minus C along the y-axis. So the final point will be here. So if you can join this point origin with this point over here, so this will be the direction. Okay, so this will be the 1, 2, -1 direction. Okay, well, it is not necessary that this line have to intersect at this point, but depending on how you draw it, so this may be over here, but anyway, this is how you can show this direction. Another way for showing this direction is to limit our direction within the boundary of this unit cell. Okay, within the boundary of this unit cell. So in this case, I can draw this unit cell again. So this is the same unit cell. Now I want to limit myself within the boundaries of this unit cell. So for this purpose, I think I need to take the I need to divide these directions by the largest of these values, so which is 2. So if I divide it, then it will become, the first value will become 1 divided by 2, the second value will become 1, the third value will become minus 1 by 2. So I need to show these directions over here. So in this case, the direction line will not go outside of the boundaries of the unit cell. So this is another way of representing the same direction. So in this case, the first coordinate is 1 by 2. So 1 by 2 along the x-axis, and then the second coordinate is y1, a distance of 1 along the y-axis, and the third coordinate is a distance of -1 by 2 along the z-axis. And now we can join this point with the with the origin. So this is another way of showing this direction. So you can represent it like this. Okay, so this is so in this way we are limiting ourselves inside of the boundaries of the unit cell, but not completely. As you can see that I am going, this direction is a little bit outside of the direction. So there is another way of that. There is another way of showing the same direction, but in that case it will be a changed origin. Well, this is also correct, but let me show you another way of this. So for this purpose, uh, what we will do is we will change the origin. Okay, so the original origin is here at point O, and in this case we will change the origin in a way where at that place where the coordinate is negative. Okay, so for example the coordinate is negative at this point C, so we will take the origin at here along its z axis, and now we will draw the points. So from this new origin, so this will be our new origin, and then from here if you go 1/2 distance along this x-axis and 1 distance along the y-axis, and then 1/2 distance below, and then that will be the point for the direction. So we can join this point for the direction with the tail from the new origin. So this will be another way for showing this direction. But now you can see that in this case the direction arrow is completely inside of the unit axis, okay, or in the unit cell. So this is the same direction as 1, 2, 1 bar. Okay, so actually there are 3 different ways. So all the 3 different ways are equivalent to each other. Okay, because since we are only talking about the direction is the same whether you take from this origin or this origin, or whether from you extend it, or whether you don't extend it, or whether you extend it. So directions are the same, equivalent to each other.